Hey there, my name is Alejandro. Welcome back for day 330 of me doing Daily LeetCode Challenge with 31 years worth of green contributions here on GitHub. So today's runs for June 11, 2025. Without further ado, let's get straight into it. Okay, for today's video, I'm keeping my tabs as minimal as possible, just my GitHub and LeetCodes, my canva.com for the thumbnails, stuff and so. Okay, seems like this is a problem so we get a LeetCode hard today, something we've attempted. I'm gonna first clear the fact that we have this over here. I don't like the fact that this is an attempted. What? 19%. Jesus Christ. Okay. February 1st, 2025. I wonder, that can't be a daily, so it must be probably some contest, probably question 4 of some contest or something like that. 20% acceptance rate, that's actually, or 19.6, I think this might be the lowest I've ever seen. Maybe I've seen like a 13% or something, but like, yeah, this is definitely in the top 5 lowest acceptance rates I've ever seen. So this is going to be a mega hard today. Okay, not that fun. And by the way, I saw your guys' comments on YouTube right before I started videoing this. I will reply as soon as I finish this recording right here, but thank you for the kind words. I really appreciate it. Oh, my roommate's here. Okay, you're given a string S and an integer K. Your task is to find the maximum difference between any frequency 2 characters, frequency A minus frequency B, and a substring subs of S, such that subs is the size of at least K, character A has an odd frequency in subs, character B has an even frequency in subs. Oh, I guess it's the continuation of the other one. Return the maximum difference. Okay. Your task is to find the maximum. Subs. So subs is a substring. Subs has size at least K.
Okay. Nice. Very
good. And what? This must be like oven or something? Yeah. Consists of digits 0 to 4 only. Okay. Okay. So basically you can't just do every substring. So this isn't that it's hard to solve, it's hard to solve in O of N. So yeah, we're definitely going to need some type of sliding window pass. Now I'm kind of terrified by the 20% acceptance right here. Well, since there's only 4 characters, it's O of 1 to look at. So right, but the only thing is going to be like, how do you know to keep growing or shrinking, right? Because growing can help you, yeah. Well, maybe you go through all possible cases, right? Since it's only 0 to 4, right, there's 5 possible options, right? So it's like you either do highest odd 5 and lowest even 4. But even if you have dp of ij, like that's n squared. Because for each one, as long as you do of n work, you could be like, you have the full string, and every time you like delete something from the end of the sides. Now the only problem is when you have. I could do something like that, right? For unique characters. One, two, three, 4.
Si ahí hubiera, no sé, cerrado y hecho la cocinita más grande. Escucha que tienes que mantener a los employees happy, ¿verdad? Te va a pagar bien, ¿sabes?
Right. So we're going through every single pair. So 5 times 5 is 25. Assert that sorted set of S is equal to unique characters. So first of all, I just want to do that.
La playa está bien, ¿ya? Te veo bonito, pero tienes que darlo suave, cerveza. ¿Estás quitado? ¿Verdad? El domingo, ¿no? Carajo. Dale, Rico, cuídense ahí.
Set of S.
Dale. Dale.
Okay, there we go. From right is equal to 0. Alright, well we have a substring of at least size k. Alright, it's going to be 0 initially. I don't care that I do it for each of these. I'm going to consider that 25, so that's constant many times. Okay. Do that copy. Predict. This will be that. Okay. Well, this should be like 5 numbers now. Dot items. Alright, so that way we just make sure that it's new. So diff equals lambda Sorry, I was gonna take the trash out. I'm just doing the liquid real quick. By the way, I'm getting one that's, I think this might be one of the hardest LeetCode problems in terms of acceptance rate.
What is it?
It's 19.6. Usually 25 and below is like death.
This LeetCode doesn't know what hit him.
Yeah, for sure. I'm LeetCode Kingpin for sure. Not even close. Yeah, we'll just get our difference. Oh, the thing is, it might change dynamically. No. Get diff is lambda. Negative infinity. If d of a modulo 2 equals 1, d of b equals 0. Right, I could write a dp function to do this in 2D, which is too slow though. There's this and diff. There's this and diff. Right, now we need to know whether we delete the character from the right or from the left. Alright. Now figure out if to delete case 1. Oh, that's where the greater than or equal to k is going to come in, right? I can't just be greedy like this. And we can try. Same thinking. Okay. I have to delete an A or B character when it's inconvenient. Choose left for now. Yeah. Oops. Unknown network error. I need to log in. Really now? Okay. Alright. Okay. Why -1? Oh, I see. Alright, yeah, let's do that. Zero to 4. 1, 2, 2, 3, 3. Continue. I'll just do that. Oh wow, okay. It's accepted for these cases. Let's submit and see where we get it wrong. Yeah. There's no way we're just flying by, right? Yeah. Yep. As expected. That doesn't make any bloody sense. They should have been ignored. Maybe I should put this in here. Break. Right, because I can only delete characters. Okay. There's no way this problem is this simple, right? There's just no way. Yeah. 607 out of 690 though. Quite impressive. Expected 1. Here it might just be like, you know. D of S of R minus circle 1 or minus circle 1, right? I don't know which to pick. I'm just picking left for some reason. And yeah. Yeah, I'm gonna have, I have to be careful. It's like I have to know, like, when, like, this is where the greater than or equal to k in length part comes in, right? Because I can't just be deleting left or right recklessly. I have to consider when I get closer to an A or a B again. this can be one of those. Alright, we can do, alright, like this is silly, right, but like, might as well do this, just really show, right, it's like maybe you get lucky, right, run this enough times and maybe you get lucky. Yeah, so now we're getting into the territory of why this is going to be a LeetCode hard. 0, 1. One, 2, 3, 4, 5, 6, 7, 8. 7, 8. Interesting. Yeah, we have to figure out what is the actual answer here. An odd 0. Or, wait, if we delete a 4, is that it? If we delete a 4, then we'll have 1, 2, 3 4s. Out of 1, 2 1s is actually equal to 1. So when A is the odd one, so here let's just do for A and for B and 1. Just for debugging. D equals Shane. Now R equals so I'm deleting from the right for some reason. Case 1A. One B. 2A. 2B. I. 2BI. 2BII. Let's see what we print. Jeez. Oh, I see. It's because we first choose like, oh, delete count. Sure. That's not A or B, right? But it ends up being naturally greedy. And in a case like this, it instantly fails. Where you actually want to delete such a character. So really, we should probably make this go under the case 2 ladder. Alright, so now we've passed that one. Okay, now submit. $6.16. Yeah, we're just gonna keep failing cases, right? Jesus. Alright. This will be case 1. So this will be 1A. This will be 1B. Case 2. This will be A. This will be 3A. 3B. 4A. 4B. So I put -1 when it's really 1. Oh boy, 6, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah. Yeah, because I definitely don't want to resort to DP where things are n squared and definitely going to be too slow. It's not exactly playing. Right, and you can't just pivot at a certain start point, because as you go more, it's like, ah. Or maybe that is the way you solve it. Yeah, that fan is amazing, by the way. You keep track of when the next index is for a certain character, and keep track of how many. It's just annoying, right? The 0-1 zigzaggings. Right, for this one, what I need to do is first figure out what is the actual correct answer. we will call def brute force solver self as k. For j in range. Okay, now we're back to laggy computer lands. I'm sorry if the recording freezes. I generally don't know what to do with this computer. I have the least amount of tabs I possibly can. Technically, I can remove my Canva, my YouTube, and my docs, but like, you know, this is just for later. I plus k. Alright, I plus k, would that make sense? If k is equal to 1, then 0. 0 plus 1 is 1. That's like, that's of length 2, right? So maybe I can do this minus 1. Let's see if it makes sense. Yeah. Frac and 1 minus min of values, if not frac and 1. Right, modulo 2 or and 1, same thing. Res equals max of res comma diff. Turn res. This float of negative infinity. Self dot root for solver is going to k. Here we'll just do Really. Yeah, okay. So it's 2 and 3, right? Obviously something like this is just gonna be way too slow, so we can try to see like what happens, but like this obviously TLEs. But now we have a brute force solver. So it's saying to delete only from the right. Right, yeah, 67, 690, makes sense, blah, blah, blah. So yeah, so now we have access to a brute force solver. That's cool. So now we know it's 2 and 3. So we can just do something like 2 and 3. Done. Yeah, I mean, I'm doing it randomly right now. That doesn't even seem like my issue. Although, yeah, right now I'm just wrong because of this. Right. So now I can undo that. And, oh wow, so now I'm failing something else as well. That's fine. Yeah, I honestly should just do if false, right? So here I'm choosing to do the left. Why? 2 and 3. I'm like, oh, why delete a 3 when you already have an even amount of it? Actually, no. I want to make sure that I delete 3s if I can. Oof, it's tough. But I need to be able to look forward in time. But then it's like, just as much as I could like delete two 3s, it's like maybe that took me 5 steps and I could have added 5 more, or like 4 more of the other ones, right? It's just, So really, that's what you gotta do. You gotta think of this in terms of sequences of 2, right? How many indices until I can either delete 2 3s? Oh, but then you might delete one or the other. Okay, this problem is actually just gonna be super annoying. You're definitely gonna need some type of tracking of when's the next index and previous index of every single character. Like you basically need a linked list, right? gosh. What do I do? Because that's like, I'm like, okay, how many A's are in the way of me dealing the next two B's? If it's not even, then I can't just delete the next two B's. Then I have to delete 4 B's, or 6 B's, 8 B's, right? And at the beginning, I might not necessarily have like, you know, an odd amount of A's or B's. And I might be like, oh, let me just get to a point like that. No, because you could have gone into there another way, right? By deleting attributes in the process. It's just so. I doubt that I'm gonna be able. No, but you have to be able to do this like greedy somehow, because you need to be at all event. But then it's just like, you know, when to greedily start deleting the one that you're trying to minimize versus like being like, oh shoot, I'm not gonna have any more of that one, right? Yeah, order's not really gonna matter here. Yeah, but this is just nonsense at this point. Yeah, like now I'm gonna fail the 7 because of ordering stuff. Yeah, this is just not gonna be okay. Okay, I'm gonna look at the hints for this problem because, yeah, this is actually kind of a crazy problem. There's gonna be way too many nuances to take care of, so you know what, I'm gonna get straight into it with hint number 1. Fix the 2 characters. Makes sense, we've already done that. So that's one of the very first things I realized. Use prefix sum, maintain 2 characters parodies as status. Yeah, interesting. Yeah, some type of like next index stuff. Prefix sum, okay, of what, each character? Well, for each fixed 2 characters, yeah, this is something that we already came up with. I guess we don't mind doing event time in here, so I could do prefix sum for each one. Right? I could do frac of B equals 0. Yes, try equals A. Frac of A plus root of 1. Try equals B. Frac of B plus root of 1. prefix a, loop invariant, dot append prefix sums, prefix of a, or bracket of a, prefix b, dot append bracket b. Okay. Use prefix sum though. Yeah, you can get prefix sums to get the count of any subarray. Is this where some sliding window action comes in? Just to be able to do stuff in over one time? I already could do that though. Just with a dictionary. Basically the prefix sum is just only useful to do what I was already doing with my delta dictionary. So I actually didn't get any new information here. Right, it just allows you to do the exact same thing. Right, prefix sums, or you just have a dictionary. I mean, it's just prefix sums is a little sexier, right? Just because it's like it's fixed for those values, you don't worry about anything else. The O1 stuff is a little bit faster. At the end of the day, the asymptotic complexity remains the same. Assuming hash maps are like, O1 stuff, even though they're technically worst case O(n) stuff. Yeah, prefix sums is just sexier, but it doesn't really advance the problem state in any way. Prefix sums, huh? The thing is, yeah. As you advance the window, right, it's not like you're trying to minimize or maximize the window itself. You're trying to find a valid window and then get the difference. Yeah, the K thing just made it so that my greedy solution wouldn't work, which is frustrating. It's of length at least K, right? Is there like one of those problem inversion principles I can do? No, probably not in this case. So out of all the valid substrings, get differences. Yeah. Might need to look in the discussions to see what people are saying as hints. Because yeah, prefix sums are sexier, but they don't actually give me any new information that I wasn't already encoding already, right? Like if you're just trying to find the frequency instead of a subarray, I already had that in over one time. Just prefix sums also being over one time doesn't actually really add anything of value. Or wait, if I do dp of I, if I knew the index I started at, wait. Then it's like, Yeah, and also let's move myself here. What was the answer for case 1? -1, yeah? One where this is odd and this is even and greater than 0. So as long as I start at k or more. Wait, is that it? No, I can do any subarray. Ah, gosh. Yeah, no, because I need to be able to subtract things. So I need to know which I to start from. Yeah, no, that becomes n squared. Right, basically for I in range, or j in range. Right. Right, but then this is going to be too slow. So then we got to figure out how to do this. Somehow sliding window my way through this double for loop here. Okay. Yeah, 670, 690. Because then it becomes about what to include, what to delete, right? Or do you just delete stuff from the left? You grow and you delete. I'm just gonna grab some peanuts here. Pretty good actually. Trader Joe's nuts. This is actually pretty good. I shouldn't have hated on peanuts. I just remember that video by iDubbbz. It was like he got Planters peanuts or mixed nuts, and the can said like it has less than 50% peanuts, right? And so then he did an experiment where he like got 3 cans of Planters mixed nut cups, and for each of them he separated out the peanuts from the mixed nuts and weighed them in grams, right? And in like one of them, it had like 50.5% peanuts or something, or no, it had exactly 50% peanuts. And like, you know, he's obviously kind of trolling, but he's like, I'm fuming, right? It said less than 50% peanuts, and this one has exactly 50% peanuts. This is the end of the world. And so then he calls like the HR lady, like, you know, he's like, I cannot believe this, and so on. Like, oh, that's a joke. And so yeah, so then it's like, you know, it became a meme to like hate on peanuts, right? Like, oh my god, 100% peanuts bag, this is just terrible, right? But I didn't realize I actually like peanuts. So there's it's just been such a funny thing for me to hate on peanuts because of that video. The peanuts are great. Just happen to also be very caloric. How are we gonna do this, right? Like, there's definitely gonna be some sliding window like idea. DP works, but it's also gonna be unsquared. Or is it? Like, can I do DP of I? Maximum subarray. That starts from index I. Oh no. Oh no, it doesn't work. The DP is not going to be recursively. It needs to be recursive in nature. You can't just make it look until the end of the string. That doesn't make sense. But how do you sliding window when things are like 1 and 0, up and down, right? Okay. I'm gonna look through the discussions. It might just be what I was doing already. It's like all the statements, but you just gotta coordinate some logic correctly and so on. So I'm just gonna look at what people have been saying and look for the hints guy. Yep, 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 yep. Yep, 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 yep. Okay, so it's just people complaining. Oh gosh. Five times 5 and times 4 is interesting. That times 4 is a huge hint. 5 times 5 is the number of characters. Times n. Times 4. So he's doing 4n work inside the body of each two fixed characters. 4n. Oh, he's doing DP. Oh, he is doing DP of index. You just keep track of even odd. Oh my god. I see what's happening here. Face to face with greatness and it's strange. Open your eyes. Let's begin. Yeah, because if you keep track of even and odds, then you can use DP recursively. You can make the subproblems based on the others. Open your eyes. Okay. I'm excited. The only thing is, like, alright, I'll just be honest about what's going on inside my head. I need to use restroom. But I also don't want to end the recording because I don't have any more video exports for the rest of the week, which means that, like, I need to upload this as one recording. I get 2 per week. CapCut, they used to make it free every single day, so I just used CapCut all the time, and that's how I was able to cut this little snippet at the beginning of the videos. But now CapCut has made it so that it's only twice per week, or unless you pay for Pro. Since I'm a cheap boy, I'm not paying for Pro. But yeah, that means it's like I need to do the recordings in one shot and so on, which makes it awkward in moments like these where I have to go to the bathroom. Which means if I go to the bathroom, it'll just be 2 seconds for me to just go in back. All right, I think I'll just do that. So, I will be right back in literally just 5 seconds. I will not cut the video just because I can't. I need to make this in one shot. But, this video is over an hour long. I hope that a 5 second little break will not be too much. So I will be right back in literally just 1 second. With greatness such strange, in your eyes, let's be. Okay. Oh, I love that fan. We bought a fan because it gets way too hot here in Seattle, which of course I break my knee when it's summertime and it's pickleball time and all fun with that. Oh well. Whoa. Yeah, this is all I need. This is the only hint that I need. Yeah, that's the only hint that I need. Aditya, I will give you a vote up. Whoops. I hope I'm not freezing here. But yeah, here I'm definitely gonna need some kind of def. I can be lazy here. How do you... Yeah, but still, this was the problem, right? So now we have, like, we're basically being told that it's possible to do DP. Because you'll add of the case being odd. Yeah, no, it's important to make them booleans. Like right now, just get like frequency of A, frequency of B, because then you could have the whole string and make it n squared. Okay. All right, for the time being. All right, let's write this dp function. All right, it'll be case 1, include index I. Case 2, don't include index I. Base case. Always return 0. Right, you'll just do plus 0 for I equals n. Right, you'll just compute basically A minus B, but you'll only consider solutions where it is the case that A's frequency is odd and B's frequency is even. But otherwise, the result will be A minus B. At I equals n, you have 0 more A's, 0 more B's to add. Right, case 2 will simply be equal to cell.dp, I plus 1. We didn't change is odd, we didn't change is even, we didn't change anything, right? It'll be 1 more A, right? 1 more A. Not is odd. As well as is even. L if S of I equals B, case 1 equals -1 plus self.dp. I plus 1 is odd, not is even, which might be necessary to make this, actually even. Alright, there we go. Something like this. And now we'll just say, whoops. Oh, here I do self.dp somewhere. Yeah. Just dp. Oh. You need it to be at least a length k. Yeah. That's another constraint. Yeah, this won't work. Actually. We cannot have 0. At this point, I'm just stress eating peanuts. Oh no, that's not what I want. Yeah, but if you're doing a DP solution, it's at least k. What the heck? Okay, I'm gonna need a bit more hints. I don't know what that guy did, but that's just a solution, so I don't want to read that. Yep. Complementary state, which when subtracted as a prefix, oh, this is subarray, not subsets. Maximum. But then inside my DP, I'm gonna need O of n logic. Like, that's the thing. Like, that's what was turning me away from DP, was the fact that I couldn't figure out a way to do O of 1 relations. You guys talking about a sliding window? Yeah, there's definitely something very interesting going on. Interesting. Just, I understand kind of what he's saying, but just, it's... I need this fan to blow on me. Nice. Prefix of a. So if I start at index 0, then I need it to be at least of size k. Alright. So let's do... Oh, I see. I see. So at index 0, Ooh, so at index 0, it's like, okay, I must have at least the first k elements, right? And then you might have an even or an odd amount of a's. And it's like, okay, what's the best DP solution starting from the next index? That and that. You feel me? You go through every single index I, up to n minus k. Always leave yourself at least k elements to choose from. Grab those first k. Prefix sums are useful here. Then it's maximum subarray with a condition. But if for each index I do O of n work, it's garbage. Well, that's just why I need some type of DP here. Right. I can't make the DP part of the K, but that's fine. That's fine. It's actually completely fine. So DP is not going to take account. Oh, and it wasn't even part of the memo. That's why it was failing. Low. That makes sense. Yeah. Right. Because now DP is going to be all the way up to what? N minus k. If I do, let me just do some quick math here. If I do n minus 1 minus n minus k, well, n, because n minus 1 minus n plus k is equal to k minus 1 elements. N minus k minus 1. Because then n minus 1 minus n plus k plus 1, n subtract, 1 subtract, and there's just k, right? But then I want to include this one, so plus 1, right? Okay. Okay. Fine range here. Subarray starts at index I. This subarray must be of length at least k. Right, so here's what we'll do. This. Plus k minus 1, right? I plus k. Oh, no. Oh, no. Wait. Okay. I plus k minus 1 minus I plus 1 is equal to k elements, right? Yeah. Plus 1 I do n minus 1 minus n minus k plus 1, and I just n subtract k. So n minus k I want to include plus 1, right? If k is equal to 1, oh, this is confusing me, okay. Right, once I'm at n minus k, yeah, n minus k plus k minus 1 is n minus 1 here. This should be fine. Frac minus b frac is dp of, so index j we're already including, j plus 1 a underscore frac 2 equals 1, b underscore frac modulo 2 equals 0. Something like this. Not quite. Yeah, makes sense. Where's that huge string that I print all the time? Or if I don't include index I, since this problem is about subarrays and not subsets, have to terminate here. Right, are these all overestimates? Yeah, right? Yeah. 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 Okay. But still are. Age frequency equals I to j inclusive. J minus I plus 1 will be exactly k elements. So oh, because it doesn't want to allow a frequency of 0. Okay. Yeah, frequency of zeros is what's messing me up here. Okay. Okay. So perform. Right, there we go. So here we'll say L comma R is equal to I plus k minus 1. And minus 1. Right, and these things only get bigger, so that's fine. Okay. And 0. Refrac 0. Index J. Look for ones 2. We'll call it leftmost. Leftmost. Index. Valid. Left. Plus 1. here I can just do. Continue. Goes like this. Really now. What do you mean dp is equals 0? Frac equals b frac equals. We're on the right path here. I know it, but b frac should be 1. Oh, there we go. Okay, submit. Wrong answer. Oh boy. What's wrong with this one? String. Versus none. And then all of this stuff anyways. Yeah, okay, so we're gonna deal with leftmost nones cases. I want to see what the brute solver tells me. It was 0 and 1. That was the brute force. Wait, actually, I need to figure out the indices. From 0 to 6. 0, 1, 2, 3, 4, 5, 6. So 0 and 1, 3 zeros and 2 ones. I could have just taken the entire string if I wanted to. Or 0, 1, 2, 3, 4, 5, 6, yeah. Why did I even get rid of a 3? The hell was the point? It just gives me one of them. So 0 and 1 and basically the whole string is fair game. Maybe something like leftmost is equal to R. No, I do not like that. So we'll run a brute force solver and just do this. Alright, I equals 0. 0, 1, 2, 3. I could be greedy and just do that. Like, I could do something like this. Right? But, that, like, it shouldn't be necessary, right, with my code. Like, that should not be necessary. And we might still fail something else. Right? Just because I passed that doesn't mean I'm proud of that. And yeah, rightfully so, we fail something else anyways. So we'll use this guy as a test case. And yeah, this should not be necessary anyways. So we should just do greater than 0 here and greater than 0 here. But I'm gonna go back to the debug mode, which is to do this, and this, and this. Yeah. Completely agree with this judgment. Let me do this, this, and this. A quick submit. And that way I'll get back to the other one that I failed. Just because I want to see it here on the left. Alright. So yeah. 1, 2, 3, and 1. That's totally good. 0, 1, 2, 3. So then I'll do leftmost plus 1. Right? J equals leftmost. A frac minus B frac. dp starting from j plus 1 where it's like, here we're told, yes, this is odd, and this is not even. So even though I'm only subtracting by 1, I need another 1. So here we're saying dp is equal to negative infinity. When that's not true, here I can pick up this, 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 and this. So dp is showing negative infinity when it really just shouldn't be. Right? I'm giving it k plus 1. Right, so what do you do? Aha. Case 1. Right, that's what I'm missing. Yeah, boy. Yeah, boy. Yeah, because you still include stuff. You're just including a non-A or non-B letter. Okay, so now it's Daily. Case 1, case 2, ask case 2. Yep. 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 Okay. Prints can become hashtag prints. That's one thing. Oh, I'm doing a brute force solver. I'm an actual idiot. I'm an idiot, I'm an idiot, I'm an idiot. Now this should be fast enough. At least a lot faster. And there we go. Bada bing, bada boom. Completion is 330 days. Consistency is key. See ya tomorrow. Oh my goodness. I think we have the world's fastest solution ever created. Yeah, I think that's the slowest I've ever gotten a LeetCode submission for. Holy crap. Oh, my eyes, they burn. Yeah, we don't need Mr. Brute Force no more. Yeah, this is useless now. Yeah. Here. Wait, do we need to refresh the memo every time? Because now this is oblivious of everything. Ooh boy, we actually just made our life better. Delta memo equals this. Memo equals delta memo. Becomes self.dp. Except for this one. Alright, so something like this. Yeah, it'll just be the same A and B no matter what. I'm just not going to memorize those. And literally how. Oh no, it is dependent on the A and the B. I mean, there's only constant many such things, but still. Yeah, this thing is not the fastest thing in the world. Yeah. Then no problem. We'll just keep the DP function local for each one. So here it's fine. Okay. Jeez, man. My eyes are actually burning. And all of this can just go. Holy crap. Yeah, I could improve some of one stuff, like I could just not have to look up things in there every time, but like I'm not gonna get to the point where I'm at 800 ms anyway, so might as well leave it as is. Oh, my eyes. My beautiful eyes. I'm gonna take 1 second just to put water on my face. Woo. Oh, I'm so glad we have a fan. This thing is just amazing. Holy crap. There we go. There we go. Now I just got to the solution explanation. Oh boy. Alright. Let's get this puppy over with. Okay. So, nevertheless, as always in all my videos, I do a quick recap of how I able to solve problems. For this one, probably the slowest LeetCode submission I've ever gotten on LeetCode. I thought the cap was actually 10,000 ms. I'm surprised that a 15,000 ms solution got accepted. I ain't complaining. I ain't optimizing this. Well, I could optimize some of the O1 stuff, but even if I did, I still think I'm going to be over 10,000 ms. I'm not even going to get close to 855 ms, and I probably could do it with, like, you know, bottom up DP instead of top down, just like things that I really don't care too much about. So essentially for this problem, I won't get too much into the weeds of what I was trying to do at the very beginning. I'll just let you know that eventually I did look up at the hints. Fixed to characters is something that I did come up with. Prefix sums is something I didn't. And I realize now that prefix sums are useful for the solution that I wrote now. Whereas before I was just keeping track of a dictionary, because the key to this problem, one of the keys is realizing that S only consists of digits from 0 to 4. Okay, first of all, let's read what the problem is. You're given a string S and integer k. Your task is to find the maximum difference between the frequency of two characters, frequency of A minus frequency of B, and any substring, not subset, substring of S such that the substring is at least k in size. Character A has an odd frequency in the substring, character B has an even frequency in the substring, and maximizes the difference. It's basically yesterday's problem, right? Except that now it's not just the full string, it's any substring, right? Now the problem, and the reason why this is a LeetCode hard, is you can't just apply yesterday's code for every single substring, right? Because you must write a linear time solution. an O of n solution, right? You can't write an O of n. Well, brute forcing would be O of n cubed, but like, you know, you could write a little bit of smart code to write it in O of n squared time pretty easily. The hard part is writing this puppy in O of n time. So this is one of those LeetCode hards where what's hard is not solving it, what's hard is solving it efficiently. So what I ended up doing is, I looked at the hints and I looked at the discussions here, and there were two that really helped me. One of them was this one over here by Noah, so I'm going to upvote this guy. And another one was done, I think it was at page 4 or something. It was, is it in here? Yeah, this one over here. Why does my O 5 times 5 times n times 4 solution, TLE, and then I saw this guy started mentioning DP, so that's when I started thinking about dynamic programming. I did think of DP at some earlier point in the video, but I didn't think about putting odd and even as variables, because Booleans only have 2 states, so you can essentially think of them as only, like, you know, multiplying the number of DP problems by a constant factor, right? True and false is 2, true and false is 2, so it'll be like, you know, there's n possible indices times 2 for each permutation here, times 2 for each permutation here. There's n times 4 subproblems, which is still O of n subproblems, right? Okay. So the way that I did this is, first of all, we got to recognize the fact that the amount of unique characters in the string S, which they tell you in the constraints here, is only from 0 to 4, meaning there's only 5 unique characters, right? Which really means that inside of any substring, right, there's only 5 characters that you can really just choose from for choosing, you know, a character for the one to be the, the one that you use for the odd frequency one, and then only one character they can use for the even frequency one. So very quickly what I realized is you can essentially say, okay, grab the unique characters inside of the string S, you know there's only going to be at most 5 of those, and then just do a double for loop on every single unique character in S. We call A for a unique for each unique character, because A will be the one with the odd frequency, B will be the one for an even frequency. These must both be a character, right? A must be a character from 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, or 4, and B must be a character from 0, 1, 2, 3, or 4, right? There's only 5 times 5 equals 25 possible permutations here, minus 5 because you don't want to include the cases where they're equal, so really just 20 valid permutations, right? So for A, unique characters, for B, unique characters, well, you know that, you know, if I choose the same character, I can't have it both odd and even frequency, so, you know, if A is equal to B, we can ignore that case, right? But otherwise, we're going through every single pair of 2 characters and be like, okay, let's do the case where, like, you know, character A here is odd and character B here is even, and see what's the maximal difference. So that was hint 1. I figured that out on my own, but it's just a very nice little trick. Fix the 2 characters that you're going to do the problem for. So, you know, it's going to be one of these 20 possible pairs of characters. You might as well go through each and every single one and find the best solution for each one, and then just take the max out of all those, right? Then what do we do? I'll just go through what I do, and then hopefully it'll make sense as we go on. So the very first thing I do is I'm going to do the prefix sums. So what these prefix sums are essentially going to be the prefix sums of the frequencies of the character A and the character B. So prefix sums, prefix A at index I, where essentially, yeah, like prefix A at index I will equal sum of, you know, the number of times char A appears in S up to I inclusive, right? 0 to I. So this is essentially prefix X, char X appears in S 0 to I, right? So prefix A at index I will tell me, okay, how many times does X appear in the string S from index 0 all the way up to I. And the nice thing about prefix sums is that essentially you can use them to find the sum of any subarray in O one time. I can show you later, but like a quick run through of it is basically, if you have this information, right, let's say you want to know what is the number of A's in S from I to J, right? And what you could do is, you know, prefix A of J is equal to number of A's in S from 0 to J, right? And then you know that this of I minus 1 will be number of A's from 0 to I minus 1, right? And then you know that number of A's in S to I to J is the same thing as the number of A's from index 0 to I minus 1 plus the number of A's from I minus 1 plus 1 is equal to I to j, right? So the number of A's from from 0 to j is the same thing as the number of zeros from 0 to I minus 1, and then continue onwards from I to j, right? Because we want, the number of A's from 0 to j. Doesn't matter where I stop in between. If I get the number of A's from 0 to index I minus 1, and then I get the number of A's from index I to j, then I have the total number of A's from 0 to j, right? And then you can essentially just refactor this equation, right? Essentially bring this to the right-hand side and bring this to the left-hand side. So then you just have this is equal to this minus this guy, right? Which means that this guy, right, number of A's in S to J, is equal to what? Number of A's in S from 0 to I minus 1. Well, number of A's from 0 to I minus 1 is just this value, right? Oh, sorry, I messed things up here. Yeah, by making this negative, yeah. So really, it's just this guy. I should subtract this onto the left-hand side. So yeah, sorry. Right. Basically, I'm keeping this is this part here. So I'm just gonna take this side of the equation, subtract it from here, and subtract it from here, right? So then the right-hand side just becomes number of A's from 0 to j, number of A's from 0 to j, minus number of A's from 0 to I minus 1, minus number of A's from 0 to I minus 1. So now we take this 0 to j. Well, that's just prefix of A of j, and then minus what number of A's from 0 to I minus 1, well, which is just this, right? And obviously, if I is equal to 0, negative 1 doesn't make sense. So that's why I add another thing, which is if I is greater than 0, if I minus 1 is greater or equal to 0, else 0, right? Because there's just no A's if you're doing from 0 to j, and that should be fine. So that's kind of the roadmap here. So basically, it's like what I'm trying to show you is when you have prefix sums, which just give you number of characters from index 0 up to an index I for every index I, you can then in O of one time figure out the number from any substring from any I to any j, right? So that's just a little trick that, in case you're not familiar with, that's very something powerful with prefix sums. Prefix sums, you just spend O of n time building, and then you can get the sum of any subarray depending on whatever values you use. In O of one time, right? In this case, we're just tracking the number of A's or number of B's, so we can track, okay, for any substring of S, right, from any I to any j, what's the number of A's or what's the number of B's, all in O of one time. Okay, so then what we have is, okay, I have a DP function, so let's clarify over what's going on here. What I'm going to do is say, hey, we have an A and a B fixed, right? We want A to have odd frequency, and we want B to have even frequency. And we also know that whatever substring I have, it must be of size at least k. So I know that for this current A and B that we have fixed, because we're going to go through every A and B to find the answer at the end, the best answer, well, the answer is some substring. A substring starts at some index I and ends at some index j, right? I don't know which index I to start from, and I don't know which index j to end at. And I can only do O of n work in here, right? Here there's only 20 permutations, but I better only do O of n work in the body, or otherwise I'm going to go way out of bounds in terms of the time complexity. So one thing I can invest in is like, okay, I don't know which starting index to start from, so let me try them all. Well, I'm not going to go for I in range all the way up to n. The only reason being is that since my solution has to be at least size k, it doesn't make sense for me to check anything past n minus k plus 1. Not inclusive here, because I need to leave myself at least k elements from index I onwards to be able to pick, right? So the point is I'm going to try every single possible index I, and I'm going to say, since my subarray, my answer must start at some index I. Let me try them all, right? And for each one, I know that since my subarray must be of size at least k, let me grab the first k element starting from index I all the way up to I plus k minus 1 for the very first k element starting at index I. So let's try every single possible valid index I, and for each one, we need to grab at least the first k elements. Now, Here, I do a little bit of leftmost binary search, and the reason being is that, okay, I want to say, okay, just grab the first k elements, I plus k minus 1 will be my index j. But here I have a dp function, which I'll explain. Okay, I'll explain the dp function first very quickly. This dp function takes in 3 inputs. I is odd and is even. Basically, what this does is, given any index I, this will find, okay, how do I explain this? Given any index I, it will find the maximum difference of A's and B's. It does not care whether, you know, you have an odd amount of A's or even amount of B's. It'll just find you, from index I onwards, the maximum difference of, you know, frequency of A's minus frequency of B's, right? Every time it encounters a B, minus 1. Every time it encounters an A, plus 1, right? So it'll say, what's the maximum subarray, starting from index I, where I just keep adding A's and B's, right? Now, I also have 2 parameters here, which are Booleans, which tells me what is the current frequency of A and B, or at least they're parities, right? Is the frequency of A currently odd, and is the frequency of B currently even? The reason I do that is because here, whenever I want to evaluate, right here I just have some memoization. If I is odd, is even in memo, return memo this, and so on. Then it's like, here's like, for example, a base case. When I reach I is equal to n, I'm going to say, okay, I can only select 0 more A's or 0 more B's, whatever, so I just return 0. But I'm only going to do so if my A frequency is odd and my B frequency is even, right? Otherwise, I'm going to return negative infinity to completely discourage the solution from being considered, right? Because we want to return the maximum difference. So it's like, I sure bet you float of negative infinity is not what you want for a maximum difference, right? So that's going to be kind of the trick. And the problem with this dp function is that there's no way to really tell it, like, you know, make sure that you include at least k elements, right? Or at least without you using some variable like count here and so on, but this would blow up the time complexity to be O of n squared. Because there would be n squared subproblems, yada, 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 right? So you cannot encode the logic of keep at least k elements, which is fine, right? That's not what this dp function is going to do. All this dp function is going to do is say, okay, give me I is odd is even, right? Give me some index I to start from. Tell me whether the current frequency of A that you have is odd, true or false. And tell me whether the current frequency of B that you have is even, true or false, right? And then at the end, I'm just going to keep doing stuff and only return to you a valid solution as long as I reach a case where the frequency of A is odd and the frequency of B is even, right? Because that's a requirement for this problem. So here's what I'm going to do. There's only 2 possible cases, which is include index I and not include index I. Now, in this problem, it's about arrays and not subsets, right? So a case 2, don't include index I, will be terminal, right? I can't just not include index I and then start including more things because it needs to be a subarray. So subarray starting from index I. If I stop at some index, I must completely stop, right? So case 2 is the easier case, don't include index I. So here I'll say, okay, case 2 will be 0. If it is the case that my A frequency is odd, my B frequency is even, otherwise flow of negative infinity to completely discourage the solution, right? Then case 1 will be, okay, what if I do want to include index I? Okay, if I want to include index I, then there's 3 mini subcases, right? Either I'm including the character A, either I'm including the character B, or I'm just including a random character, right? In this case, let's go through these mini subcases, right? Initially I said case 1 is equal to flow of negative infinity, whatever. But I say, okay, if S of I, if S at index, or really, I should really just put char here. Because I have char up here. Right, so if the character is equal to the A character, remember these A and B, that's hard-coded, then we're going to say, okay, case 1 is going to be equal to 1 plus dp of other stuff. So what's going on? Well, okay, the difference is going to be the frequency of A minus frequency of B. If the current character is A, then I've just augmented my frequency of A's by 1. Frequency of A minus frequency of B, if frequency of A becomes 1 larger, then my total sum should be 1 larger, right? So I do 1 plus something. And then 1 plus what? Well, 1 plus the maximum subarray starting from index I plus 1 onwards, right? So here I'll do 1 plus dp from index I plus 1. But this time it's like, okay, if the frequency of A was odd, well, now I just added an A, so it's now even. Or if it was even, I just added an A, so it's now odd, right? So is odd, if it was false, I need to make true. If it was true, I need to make it false. So I'll just do not is odd, because not false will be true, or not true will be false, right? So I flip the value of is odd. and I keep the value of is even the same because I didn't change any B characters. Now here's the thing, if you come across an A character, right, and add 1, you're like, yippee, I got to add 1, this is so much fun. You might flip is odd, and then at some point you will realize like, oh, you're not odd anymore, so then you return float of negative infinity. That's why we do those discourative solutions, right? So you might not always pick character A. The point is you don't know whether to pick it or not, that's why we're doing DP in the first place. That's the spiel. Otherwise, if the character is B, it's basically the same story. If I augment the frequency of B, remember we're doing negative frequency of B, so this actually lowers our sum, right? So here I'll add -1 instead of 1, right? This actually hurts us, but it might be necessary, right? Let's say that is even is equal to false, right? We need to make it true, otherwise we're going to return float of infinity here, so you might as well, take a -1 hit and return a 0 rather than, return a negative infinity. So sometimes it might be necessary, and that's what DP will figure out for you. So here in this case we'll do -1 for adding the character B, and plus DP from index I plus 1. We keep is odd the same, but we flip the value of is even, right? Otherwise, the last case is, what if the character is not A, and what if the character is not B, right? We're just adding some random character. Okay, then we can just find the biggest substring, starting from index I plus 1, where we didn't flip the value of is odd, and we didn't flip the value of is even, right? We didn't add an A character, we didn't add a B character, we just added a random character, right? And so there we go. In case 2 we already covered, and then at the end it's like, okay, it must be one of the two cases, either we added index I or we didn't include index I, so then we'll say res is equal to the max of case 1 and case 2, so case 1 if case 1 is greater than case 2, otherwise case 2, cache that bad boy, and then just return the result, right? So that's what this DP function does. From an index I, it'll give you the maximum difference, A's minus B's, but you must first specify, like, is the current, right, number of A's that you have odd or even, and is the number of B's that you have odd or even. So here's how we use this later on. Remember, we brute force through every single possible index I, and then for each of those, we're gonna say, okay, we need to have a subarray that is of at least size k. So let's make sure we do, right? Let's make sure we do. However, we can't just pick j is equal to I plus k minus 1, which would give us the first k elements. Why? Because we want to avoid the cases where the frequency of A or frequency of B is equal to 0. We're not allowed to have substrings where the frequency of A and B is 0. Well, for A, it's already implicit, right, because 0 is not even odd, right? But for B, it's like, oh, 0 is an even frequency and so on. Really, it's like, it's annoying, right? 0 is technically an even frequency, it's just not included in the problem. So you need to make sure that B is of even frequency, right? So here I can just really just do if B frequency. Right, and B frequency. And this should be enough, actually. I don't need the A frequency greater than 0. Well, I do, it's just that by being odd implicitly, it cannot be 0, right? So it's just like, my code will already handle that. Okay. Phew! Alright, so here's what's going on. The thing is that, yeah, we need B frequency to be 0. So at I plus k minus 1, right, it could be that the frequency is not actually, whatchamacallit, it might not actually be greater than 0 for B. So we might end up having to find a larger index. So really, we need to find the first index that is greater than or equal to I plus k minus 1, such that the frequency of B will be greater than 0, right? And here, remember the trick with the prefix sums, right? Prefix B of an index mid minus prefix B of I minus 1 if I greater than 0, L0, right? This frequency of B that we're going to start from, we need to make sure that, like, hey, since we're starting from index I, right, we might not have the B's from index 0 to I minus 1. That's why we're subtracting this over here. So we need to make sure that this thing is greater than 0. So since we need to find the very first index that is greater or equal to this, where the frequency of B, which we can compute in O of 1 time, must be greater than 0, we know that, hey, this is the leftmost value we could have, here's the rightmost index that we can have, binary search, right? So we have an n log n solution here, instead of O of n, which, looking at the discussions, it seems that it's possible to do this in just O of n, but hey, sometimes O of n log n, I'm just happy I solved it, there we go, crispy and nice, right? So, in that case, all I do is a leftmost binary search. I want to find the leftmost index in the range from I plus k minus 1 to n minus 1, such that the frequency of b is greater than 0. So I do exactly that. Leftmost initially is equal to none. And I'll say, well, L is less than or equal to R. I'm going to get the midpoint, compute the A frequency and B frequency. Really, I don't need the A frequency here. And be like, okay, if B frequency is greater than 0, then we found a valid index, so set leftmost equal to mid, and then search on the left-hand side for potentially even more leftmost indices that work. Otherwise, make L equal to mid plus 1 to look on the right-hand side, right? If leftmost is none, what does that mean? Well, there's no case where B's frequency is greater than 0, which means no valid solutions, so we can just skip. That's why I just continue. Otherwise, J is equal to leftmost, set A frequency and B frequency equal to their appropriate values, and then here's the magic part. We're brute forcing solutions for every single index I as a starting point, right? The maximal solution starting from index I, right? The subarray must start from some index I, we try them all, right? That's the part that we brute force and use O of n time on. Now, we're starting from this index I, and we know that we must have at least k elements, so we know our index j, and we not only know, like, you know, just the index that's like, you know, k minus 1 larger than in the index I to have the first k elements. We also go a little deeper so that we have at least one instance of the character b, right? So we essentially have our j, right? Well, here's the thing. We might have an even, we might not even have an even frequency of b's. We might not even have an odd frequency of a's, right? We just have from index I, we have, you know, at least j, we have at least k elements, and we know that b's frequency is greater than 0 now, right? So that we don't have to worry about that. But we don't have any guarantee that b is even. We don't have any guarantee that a is odd, and we don't even have any guarantee that, like, you know, we have the maximal subarray here, right? We're just fitting to this constraint right now, right? We just have that subs of at least size k, and we just have that b's frequency is greater than 0, not even that it's even or odd. So what do we need to do? Well, we know the index j that we're currently stopping at, so we have the frequency of a from I to j, as well as the frequency of b, right? We get the a frequency and b frequency. But now, we need to continue this subarray from index j plus 1 and more to make sure that a's frequency is odd, b's frequency is even, and that our solution is as maximal as possible. So what do? We say, hey, we have this dp function here. This dp function takes in an index and will return to you the highest a minus b frequency pairs and so on, as long as you tell it, you know, if the current frequency of a and b is even or odd or not. So that's exactly what we do. We say, okay, our difference is going to be the current a frequency minus b frequency. No, a and b might not even be even or odd and even yet, right? But what we're going to say is, hey, we want the largest dp solution starting from index j plus 1, because our current subarray is from I to j, so we're going to continue from j plus 1 onwards. And we're going to tell you a frac modulo 2 is equal to 1, so it'll be true if a's frequency is currently odd, false if it's not odd, right? And b frac modulo 2 equals 0, true if its current frequency is even, and false if it's not, right? So here, for example, let's say that a's frequency is 3 and b frequency is 1, right? That's like 3 is odd, that's great, minus 1, b is not even, right? But remember, our dp function will take that into account, that is even is false, and at any point, if we have to evaluate, since is even is false, it'll just return negative infinity. So negative infinity will always be, you know, an invalid solution, so that case will just never be considered. So at some point, it will have to sacrifice itself, quote unquote, where it's like it'll have to take a minus 1 hit, right, in order to account for that fact, and, you know, flip is even to be back to true, right, kind of thing. So that's how we leverage this dynamic programming function. We just go continue the subarray from j plus 1 and add these constraints to enforce the fact that a and b must be odd and even respectively, and also dp to essentially maximize, you know, the case where it's like, you know, make sure that a's frequency is odd, make sure that b's frequency is even, but then from then on, you know, try to maximize the possible sum difference that you can get, right? And we just update res if we can. If res is less than the current difference, update res to be the current difference. So that way when we return res, after we've essentially brute forced through every single pair of unique characters, we'll just return the maximal result, and there we go, bada bing, bada boom. We have a very inefficient solution to this problem. Probably an O of n way to be able to solve it from what I read from the hints, right? It'll be just like, 5 times 5 times n times 4, which is like, you know, 100n, right? 100n is kind of crazy. Here's I have something kind of similar, but technically in terms of big O, I think my solution is O of n log n, just because of my little binary search trick here and so on. I'm not sure how people got around this little part without binary search, but I don't mind, right? When I think of log n, I basically think for free, right? It's just if I can easily make something over 1, then I will, right? Like, why use a heap instead of an array when you just need an array? Kind of a thing. But like, if I see a solution in log n easily and not so much as like a constant time, I'm not gonna bother too much in LeetCode, because like, usually in LeetCode they can't force you to write like an O of n solution but not O of n log n, right? It's kind of tricky for them. Like, they really have to make it like, n is equal to 3 times 10 to the 6, and like that way it's like times 6 of that might be getting to the times 10 to the 7 territorialization, like make it so that n log n is not really possible. But then it's like some people might write O of n solutions with bad O of 1 stuff, so they kind of want to avoid that. So usually, like, if LeetCode kind of intended an O of n solution, an n log n solution is almost always likely going to be accepted as well. And yes, it was indeed, and I have absolutely no guilt, absolutely no shame. We killed this problem. There we go, baby. That is all I care about. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and interesting to perform, I'd highly appreciate it if you left a like or a comment. But otherwise, I'll catch you in the next one. So till then, ciao, ciao, my friend. Bye-bye.